You know, we're surrounded by these absolutely massive structures, but we almost never stop to think about the invisible systems that keep them from ending in total disaster. So today, we're going to pull back that curtain on one of those systems, a crane safety standard, to really understand how you engineer against catastrophe.
Okay, first, let's just get a sense of the scale we're talking about here. Try to imagine lifting 400,000 pounds. That's like stacking 30 adult elephants on top of each other and just hanging them in midair. The forces at play are just mind-boggling.
So that's the big question, right? When one tiny mistake could be catastrophic, how on earth do you build a system where mistakes become almost impossible? The answer isn't just about getting a bigger crane. It's about having a much, much smarter rulebook. So here's our roadmap for this explainer. We're going to start with the stakes, then we'll introduce the rulebook itself. After that, we'll break down the 4 key pillars that make it all work: the planning, the protocols, the gear, and the people. And you'll see how they all come together to form one really powerful concept.
Every single time a load gets lifted off the ground, an incredible amount of potential energy is created. It's basically a high-stakes game against gravity. And this isn't just about having raw power. It's about having absolute total control. Because the second you lose that control, all of that energy gets released.
And this is the solution. Now, I know what you're thinking, but this is not just some boring document. You got to think of this safety standard as a meticulously engineered blueprint for survival. It's designed from decades of experience, all focused on managing those incredible forces safely.
You know, the standard's own words actually explain its purpose perfectly. It's a system to identify, evaluate, and manage hazards. And the key word there, the most important one, is systematic. It's all about taking out the guesswork and replacing it with a predictable, repeatable process for being safe.
You might think crane safety is all about the operator sitting up there in the cab, but actually, the most crucial work happens way before the engine even starts. It all begins with a simple pen and paper. This is called the Job Safety Analysis, or JSA, and it's such a beautifully simple but incredibly powerful process. First, you just break the entire lift down into tiny little steps. Then, for each of those steps, you brainstorm every single thing that could possibly go wrong. And finally, you write down exactly what you're going to do to stop that bad thing from happening.
But what's really fascinating is when you have to do this. The standard makes a JSA mandatory if a task is new, if it's not routine, or even if the weather just changes. It's like this built-in alarm that goes off, saying, "Whoa, stop, the old plan might not work anymore. We need to rethink this entire thing from scratch."
Okay, this brings us to the second pillar. The system is smart. It recognizes that not all lifts are created equal. Some are just so inherently risky that they get their own special classification and a whole extra layer of protection. These are what we call critical lifts.
And these are the triggers. I mean, lifting people or working near power lines, those are pretty obvious dangers. But look at that 85% rule. The second a lift is planned to use more than 85% of what the crane can handle, boom, it automatically becomes critical. That's the system saying, hey, your margin for error just got a whole lot smaller. It's all about building in safety by never pushing a machine to its absolute limit without taking extraordinary precautions.
Now for these lifts, a regular JSA just isn't enough. You need a full-blown critical lift plan. This document is basically the script for the entire operation. It details everything: the precise weight, the geometry, the communication signals, even the qualifications of every single person involved. Absolutely nothing is left to chance.
So you've got your plan. It's perfect. But a plan is just paper without the right gear, and more importantly, the right people to make it happen. This brings us to the last 2 pillars of the system, which are totally connected: the integrity of the equipment and the competency of the people.
Let's start with the hardware. It has to be perfect. The standard requires that every single piece of equipment, from the giant crane itself down to the tiniest little shackle, is inspected, meticulously maintained, and certified to these really tough independent standards.
And that level of rigor is completely non-negotiable, because no matter how perfect the machine is, its potential for safety or for destruction is ultimately in the hands of the person at the controls.
And the standard is incredibly specific about this stuff. It doesn't just say, hey, use safe equipment. No way. As you can see in this table, it points to the exact engineering standards that each machine has to meet. This gets rid of any ambiguity and makes sure there's a really high, consistent baseline for safety, no matter what.
So here's the crucial point. Competency is a two-sided coin.
The standard demands a system to make sure the operator is trained and permitted for that specific machine. But, just as important, the person who maintains that machine has to be certified as competent too. That's how you ensure those safety-critical systems work perfectly every single time.
All right, so let's tie this all together. We've talked about planning, procedures, equipment, and people. But these aren't just four separate ideas. They're all interconnected links that form a single, really powerful concept.
This is what we call the unbroken chain of safety. The plan is the first link, the procedure is the second, the tools are the third, and the team is the fourth. Each one has to be absolutely perfect, because if any single one of those links fails, the entire system fails, the chain breaks, and the load falls.
This quote straight from the standard just perfectly captures the whole philosophy. Even when you're changing a piece of equipment, the absolute top priority is making sure that change does not increase the risk. It's a system built to protect every single link in that chain, from the operator to the folks on the ground.
And that leaves us with a final thought. This idea of an unbroken chain, where the plan, the procedure, the tools, and the team all have to work in perfect harmony, that's not just for cranes on a job site. From the cockpit of an airplane to a hospital operating room, where else in your life do you rely on an unbroken chain of safety every single day?